This is Josh White with JW Math Tutoring. Today's video is going to discuss some common problem types that you should absolutely use Desmos for as part of my ultimate Desmos guide to digital SAT math. So let's go ahead and get started.
But life is a dream the calculus could never predict.
Welcome back to my ultimate Desmos guide to digital SAT math. This video is going to focus on some of the common problem types where you absolutely should use Desmos to save time and solve the problems in a quicker and more efficient manner than if you were doing it by hand. So let's talk about some of these. The first one is solving any type of equations. So these could be linear, single variable equations, could be quadratics, could be other types of equations as well, absolute value, and it could also involve ones where you are asked to find the sum or the product of the solutions. Now, for these, I'm talking about equations where there are no constants in them. Okay, so these are just straight equations where they're looking for the value of x, or they're looking for, I don't know, maybe like what x plus 4 is equal to, or something like that, 6x minus 1. Now, depending on the problem, of course, you might need to use a specific technique, such as linear regression, or not linear regression, excuse me, just regression, to solve the equation to get the exact value if it's, a decimal, not an integer, or a terminating decimal, but a non-terminating decimal. But for solving equations, that's one common problem type where I would definitely recommend you use Desmos. Another common type is basically any type of problem where you're going to use linear regression. So anything where you're asked to find the equation or slope or a point of a line or on a line when you're already given 2 points or a point and a slope, or something along those lines. And this could also involve intercept values, x-intercept, y-intercept, basically anything where you're given enough information to find the equation of a line, and then you need to use that in order to solve the problem. Like doing that using linear regression is so much faster than calculating the slope and, say, the y-intercept by hand. Third type is solving systems of equations. So this could be two linear equations, or it could be uh, a linear equation combined with a quadratic, or something else, and just seeing at how many points do they intersect. Related to this also, there are some questions where it might ask, um, how many solutions does this system of equations have? Or you could also see a problem where it gives you one equation and it says the system of equations has no solution or has infinite solutions. Which of the other equations listed below could be, the second equation in this system? And, because it's so easy there to just type in the original, type in each answer choice and just see, okay, which one overlaps it completely if it's infinite, or which one is parallel to it, if it's no solution. So that's another common problem type where Desmos, can be very helpful. Evaluating functions, meaning, plugging in an x value to get its corresponding y value, or finding an x value for a given y value. And this just kind of relates to like number 2 above there on the screen, but like, a problem where you have to find the x value for a point where you're told the y value is like, I don't know, 4 or 10 or something. And maybe you're finding the x value of a new function after translation, or of a line, a new line which is parallel to some given line or something. But the point is, the actual process of either evaluating a function, meaning finding the y value for a given x, or finding an x value for a given y, those are both things that are so much quicker and easier to do just in Desmos. Fifth common problem type is matching equivalent expressions. Now, I generally am only recommending this for the harder or more complicated ones. So what I mean by that is if you have something, like this, 6x squared minus 2x, and it says which of the following expressions is equivalent to this? Okay, and all the answers that they give you are ones in factored form. So for example, the correct answer would basically be, this right here. This is what I consider an easier type of problem. You're just factoring out GCF and that's it. You can use Desmos for this, but if you know how to do factoring, you're factoring out GCF, it could actually be quicker just to do this by hand. So when I talk about matching equivalent expressions, I'm talking about the much more complicated or complex ones. The ones where you could use regression to find the values of constants in order to make the two expressions equal to each other, or um, maybe something involving rational expressions and like um, matching them up. You have two rational expressions being added or subtracted, and they're asking for which of these answer choices is equivalent to it. Now, for number 6, uh, the topic is, it says finding a value of a constant to meet given conditions. So this is especially useful for quadratics. A lot of times it'll ask, what's the largest value of b, or what's the smallest possible value of v, such that the equation has no real solutions, or at least one real solution. Okay, so that's one common problem type that fits this topic. Now, the other thing to be aware of is, though, I only recommend Desmos be used on these problems. Generally, if it's also if it's multiple choice, and if you're told the constant is an integer. So I'll get into this in a separate video, but there are some problems where you're finding a constant, but the constant is not necessarily an integer. I mean, it could be any rational or irrational number. And especially if it's free response, those questions are just generally take way too long, depending on the setup of the problem, to complete in Desmos. So for those, um, I would not recommend you use Desmos, but again, I'll explain more in a separate video the specific types of problems that I'm talking about with regard to that. And another example is there's one type of problem where they have an equation, and the equation has a constant in it. In addition to the x's, there's also, I think they traditionally use a k, and it'll ask, what is the value of k such that the equation has exactly one real solution? And because you're not told, it's not an integer, um, and it turns out that it's actually a decimal, it's it's actually going to be faster, I think, generally, and easier to solve it by hand rather than doing it in Desmos. Next up, so for number 7, basically any type of problem that deals with finding which point or points, is on a function or a graph, or is a solution to an inequality or a system of linear inequalities. And also, especially related to this, is circles as well. Which of the points is on the circle or inside the circle? Because for any of these problems, you can just go and graph the function, the curve, the inequality, the circle, and then you can graph the points, and you can see are the points on the function, are they on the graph? Are they a solution to the inequality? Are they on the circle? Are they inside the circle? The next one, number 8, basically problems that deal with identifying the number of solutions to an equation. And again, this could also be applied to systems of equations as well. So anything where you're given excuse me, an equation, and you're asked how many solutions does it have, and the answers typically are going to be like exactly 1, exactly 2, none, or 0, or infinite solutions, things like that, because you can graph it out and you can easily see, again, using the method you want to use here, as covered in my previous videos, is, graph y equals left side, y equals right side, and then you're looking for the number of intersections. Next up, number 9, anything to do with translations of functions, so any types of shifts, left, right, up, down, these can very easily be done in Desmos, especially if you are looking at translations that deal with finding a value like of the translated function, after the translation. It's so much quicker, so much easier to do that in Desmos rather than say to do it, to actually plug it out and work it out by hand. After that, number 10, any problem where you are trying to match a graph to an equation or an inequality or vice versa. So what I mean is these could be problems where you're given the graph and then it says which of the following is, the graph of what you see above. And maybe it's equations of a line, or maybe it's a linear inequality, with shading or whatever. And then there's also the opposite of that, which is where you're given the equation, you're given the inequality, you're given the system of linear inequalities. And then the answer choices will be the graphs themselves. Okay, and you're trying to match those graphs up to the equation or inequality or system inequalities you're given. Again, very, very easy in Desmos because you can just graph out whatever you can either graph out the answer choices or you can graph out the actual equation, inequality, system inequalities you're given, and then you can see which one which matches what you get in Desmos. And then lastly, the regression of advanced functions. So when you get to problems that deal with exponential functions or rational functions or quadratics, that's the one that's cut off at the bottom here, or other types of advanced functions. Basically, I'm talking about non-linear. So for these, it's much quicker, much, much easier to do in Desmos. Where you have, if you could have, obviously points that are given, or maybe you have a graph of this function and you can identify some points off the graph, and then you can just take those and type them in and do regression and get the actual equation there, and then go ahead and do whatever it is, whatever it else is you need to do for the specific problem. So there's one more common problem type that I thought of after I recorded the original 11 problem types. So this is recorded after, I recorded the part of the video that you're going to see after this, but um, problems where you are asked to find the center and or the radius of a circle and you're given the equation not in standard form, it is so much quicker and so much easier to do this in Desmos. Just, type in the equation as it's given, use the distance formula, use the midpoint formula, get the center, get the radius from that instead of actually doing out the manual work of completing the square and putting it into um, standard form, to get that information. So this is just the last common problem type in this video. Again, if I come across others, they'll just be added to separate videos later in this playlist. So those are some common problem types that you absolutely should use Desmos for. Again, if you're not sure how to do some of these common problem types, go back and watch the earlier videos that are part of this guide. So you have the core skills, which goes over a lot of kind of basic Desmos operations and skills that you should be familiar with. Then you have the intermediate skills, which are a little bit more advanced and would tend to be used more on the medium and hard level difficulty problems. And then finally, the advanced skills, which are, focusing primarily on the hardest questions, the digital SAT math section, usually at the end of module 1 and also towards the end, the middle to the end of module 2, assuming you get the harder module. If you like this video, please do give it a thumbs up, subscribe to my channel, and sign up for notifications. Otherwise, like I said, check out the rest of the videos in this Ultimate Desmos Guide to Digital SAT Math.